Okay, my director's saying we still have a few more calls, so if you guys don't mind, we may need to go over just for a few minutes. So there's a lot of excitement and interesting questions from folks, not only on the media calls, but in the social media front. So we're going to go to Alicia Chang of the Associated Press. Alicia?
Hi, thanks for taking my question. For John Grotzinger, I'm wondering how you can declare this spot a habitable environment without a strong organic signal.
Thanks, Alicia. That also gives me a chance to elaborate on something that I mentioned before, but I think it's often and easily confused. You don't have to have organic carbon present in a geological environment that's habitable in order to have microbial metabolism to occur. For example, almost all prokaryotic organisms, they don't use organics to metabolize. They actually use inorganic compounds. There does need to be a source of carbon there somewhere, but if it's just CO2, you can have, it's a complicated word here, but a chemolithoautotrophic organism that literally lives on rocks. It feeds on rocks. Add that CO2 there, and they will metabolize and generate organic compounds based on that carbon. So the fact that Paul is able to show in the SAM that CO2 spike, that's what we're real excited about there, because then that gives us our sort of desiderata of the key elements that are the building blocks for life: hydrogen, oxygen, phosphorus, sulfur, and then of course nitrogen, and then also carbon. And it can be inorganic to be utilized by a microbe.
And let me just make an announcement. We're going to take a few more questions, and these gentlemen will be available following the briefing for the media who want to have one-on-ones. So just call my office or the JPL office, and we will get these folks to answer some of your questions. The media that I will call on, please limit to one question so I can hopefully get us out in the next 5 minutes. So next up is Ken Kramer, Spaceflight Magazine.
Hi, thanks for taking my question, and really great results. I'd like to follow up on something John just said. I'm interested to know, maybe even from Paul Mahaffey, about the SAM run. Did you see any nitrogen or phosphorus or chlorobutanes, and can you talk about what was the weight % level of the phyllosilicates? Thanks.
So I think the weight % of the phyllosilicates is best answered by Kemen, and you gave a number for that of...
Yeah, 20 to 30 weight %.
And did we see nitrogen compounds? We certainly are in our trace gases looking for those. It seems that we have some nitrogen oxides coming up. We're looking at compounds like HCN and so on. Deconvoluting those spectra requires work, and so we're working away on that. But it sure looks like we have nitrogen compounds there. In terms of phosphorus, we haven't seen any, but that really is an APXS result. They see phosphorus in their compounds. Very interestingly, we see a fair bit of hydrogen chloride coming up into our lines, and so the chlorine is not just producing these trace chloromethane compounds, but is also producing hydrochloric acid, HCl.
Next up, Peter Spotts, Christian Science Monitor. Peter?
Well, thank you very much for extending this. The one question I have for John, I think it is, earlier in this series of briefings since the landing, you mentioned that there were some tests you would have to perform once you did find organics to see if they were homegrown or came from elsewhere. I wonder if you could recapitulate that a bit.
I'll just answer quickly and then see if Paul wants to add further to that. But as Paul outlined, we're not done yet here. We want to do some more runs to enhance the signal that he's seeing in SAM. But after that, if we got a positive detection that was reinforced and we know that if there's an organic compound that's not coming from the instrument and it's not coming from the rover, then we can feel confident that it does come from Mars. Then we got two options there. The one is that there's this sort of never-ending rain of cosmic debris that occurs on the surface of the planet, and so it could be that we're detecting that. And then it could be that it is actually being manufactured on Mars. And then you have to bifurcate again in order to show that the organic that you're seeing wasn't manufactured by some inorganic process, for example, in a hydrothermal environment. And then if you can discount that, then maybe you've got something that could be a trace of a biosignature. But that's a long row for us to hoe there.
Our last question is going to be from Mark Kaufman from the Washington Post. Greetings, Mark.
Okay, thank you very much. A simple question. Everyone has talked about Yellowknife Bay as being aqueous and references to possibly a lake. Could anyone be more specific? I mean, would it be accurate to say that at this point you believe that this was a lake or something like a lake? And if so, how large might it have been?
I think, Mark, you'll continue to see us hum and haw about that one. There's obviously this unit called the sheepbed, and the geologists can map this around and see that it extends around Yellowknife Bay, and that it projects under what we call the Gillespie unit, and so it extends underneath the outcrop to some unknown distance. So, just looking around the bay, that's sort of a minimum. And but the real question is, if this was a lake, how long, how deep, what was it like, the hydrology, and that's a much harder thing for us to reconstruct. So I think it's safest at this point to just say that we see something that's fine-grained. It could have been the material that was eroded from the crater rim that accumulated within some type of occasionally wet pool. But we don't have to go much further than that, and we'll just have to see. We can still collect more data.
Okay, now I'd like to invite Dr. Grunsfeld up for some remarks, and then I will close out. Dr. Grunsfeld?
Well, gentlemen, thanks very much for that description. First of all, congratulations. I mean, really incredible, and I know it's been years of hard work to get this far. I used to hike around as a young boy with a rock hammer and a collection bag here on Earth, trying to find interesting samples, and I have boxes of rocks. I was always on the quest for fossils, very hard to find on Earth. Even if you know where to look for them. But this has just been an incredible adventure, just to get to this point and so early in the mission. That you must all be very happy. Someone asked, well, how do you feel? Just sitting in the audience here, I feel giddy because I have an image now of, possibly a lake, freshwater lake on a Mars with probably a thicker atmosphere, maybe a snow-capped Mount Sharp. I mean, who knows? And so now we have the food to imagine a very different Mars than the one that you see behind us now, the modern Mars, the Martingale crater, which is a very dry, foreboding place. Having said that, though, and looking at the image and thinking about the work that you're doing with Curiosity on Mars, it makes me want to go. And so let me just ask you, how many of you now would like to go to Mars and be able to go with a rock hammer and maybe a little more modern instrumentation? Well, at least one hand goes up.
Just make the trip short between here and there.
I'll go, John, as long as you can get me back.
Yeah, well, I think that's a critical element, absolutely. And in fact, we are going, the fact is that we are on Mars. We're exploring Mars with Curiosity. We still have Opportunity roving, Mars Reconnaissance Orbiter, Odyssey, collaboration with ESA on Mars Express. We have MAVEN on the way, hopefully this year. That's the plan to orbit Mars. We have InSight planning to land in mid-decade. We are participating with ESA on their ExoMars program, and then as Michael Meyer said, we're working on a Mars 2020 rover, kind of the cousin of Curiosity. And I think it's the questions that you're answering today. And this is a pretty big one, is did Mars, this is a huge science question, a planetary science question. Did Mars ever have a habitable environment? And we now have an answer. I think that's incredible. And we'll be able to follow that up with what we do on a rover later in this decade in 2020. I think that's pretty exciting. So with that, I just want to give you my thanks for all the hard work and keep it up. I'm sure there's a lot more surprises that Mars has for us as we rove around. Thank you.
Okay, ladies and gentlemen, that will do it for us. I want to thank you for staying with us a little longer. Congratulations to the team. And again, keep the conversation going. It is going on Twitter and social media, www.nasa.gov/Mars for the latest results. And if you need to talk, the media that did not get a chance to ask questions or would like interviews, please contact my office headquarters, JPL, Ames Public Affairs, and Goddard Public Affairs. It's a big family here with incredible results. So thank you again. Thanks for joining us. Have a great day.